here's a review question which is worth 9 marks. Let's get going. So, using a geometric approach, it's late at night, so forgive me. The modulus of z minus 4 plus 2i, as the modulus of z minus 4 plus 2i is equal to the modulus of z plus 8 minus 6i. Now, according to page 42 in your C1 book, this is a perpendicular situation, or is a perpendicular bisector. So I write that is a perpendicular bisector, excuse my writing, perpendicular bisector of the line joining, and let's call them A and B, joining AB, where A is the coordinates 4 and minus 2, 4 and minus 2, to B, which is the coordinates minus 8 and 6. And of course, this is your x1, y1, and this is your x2, y2. Then we can look at the line AB and find the gradient. So let's find the gradient. Then m, the gradient of AB, must be equal to 6 minus, so y minus y1, so 6 minus minus 2, 6 minus minus 2 over x2 minus x1, which is minus 8 minus 4, which of course is equal to minus 8 over 12, minus 8 over 12, which is equal to minus 2/3. Whoops, that is a 3. Let's just tidy it up and write 3 properly. 3. So the gradient then of the perpendicular, so m perpendicular, let's call it m2, is equal to minus 2/3, be minus 2/3 m2, which is of course equal to minus 1, because m1, m2 is equal to minus 1, which means that m2, or the gradient of the perpendicular line, will be minus 1 over minus 2/3, which is positive 3 over 2. So we have the slope of the two lines. Now we need to try to find the midpoint, because the midpoint of the line will be the line that bisects or cuts the our normal line in half. So let's find the midpoint, which will be of AB, which is equal to 4 plus minus 8 over 2. So we've got 4 plus negative 8 all over 2 is your x, and your y will be minus 2 plus 6. Minus 2 plus 6 over 2. And that's your midpoint. So what does that give us? That gives us minus 4 over 2, which is minus 2, and 4 over 2, which is 2. So our midpoints are 2, 2. Yeah, and that's equal to. Right. So now the equation, because it does ask us to find in part A, seems like a lot of work for, let's get our screen rolling. Yeah, let's go find the Cartesian equation of this locus. So using y minus y1 is equal to m brackets x minus x1. And now substitute our values. We got y minus 2 is equal to the gradient, which is 3 over 2, x minus x1, which is minus 2. And then we can have, I just do a bit of basic algebra. 2y minus 4 is equal to, we'll have 3x plus 6. 3x plus 6. And this will give me 2y, which is equal to 3x plus 10. Oh, that's nice. That gives me y is equal to 3 over 2x plus 5. And that's the Cartesian equation of the locus. Okay, part B. Sketch the locus of Z, label the points of intersection with the real and the imaginary axis. Well, we know the intersection will be at minus 2 and 2, because that's the midpoint. But let's have a look at this sketch. We have our real, and I'm almost time. That's our imaginary, and this is our real. So real and imaginary. And now we need some values, because I didn't find the value of, I got 3x. So we got 3x, y is equal to 3x plus 5. So we know that y is equal to 3x plus 5. 3 over 2x plus 5. Which means, of course, that when x is 0, y is 5. So we got a point here, and we call that 0 and 5. And here's our origin. And when y is 0, x will be minus 10 over 3. Yes? So when x is 0, x equals 0, y is equal to 5. And when y is equal to 0, x is equal to minus 10 over 3. So we know that we got minus 2 and 2 as one point, yes, because we know that we have minus 8 and 6, minus 8 and 6. We have 4 and minus 2, 4 and negative 2, and we also have minus 2 and 2. So, oops, what happened here? Let's get rid of that little nasty line. Good. Okay, so we got our points here, and let's try to draw something sensible that goes straight through. Oh, that's not good. Let's try again. Yeah, okay, I'll accept that. And minus 2 and 2. So let's have minus 2 and 2 here, about here, our midpoint, and we call that negative 2 and 2. And we've got 8 and minus 8 and 6. Minus 8 and 6. Minus 8 and 6 somewhere here, because we want to bisect it. And we got 4 and minus 2. 4 and minus 2 down here somewhere. So let's call that 4 and minus 2 down here. And let's just, so we got a bisector cutting through and going all the way to somewhere here. Okay, so there's our bisector, and that's a decent sketch, I think. Now, we need to equate our two lines. So for part C, we must say, well, our lines are minus 2/3 x and 3x plus 5. So let us equate them and solve for x, because that will answer that part of the question. So let's equate them. So we got, try and get this on the one because I'm not going to edit this time of night. So we got minus 2/3 x is equal to 3 over 2x plus 5. And we solve for x. The best way, I would say, rearrange it so that, I mean, this is just basic algebra. There's many ways to do this. 3 over 2x and plus 2/3 x. So I've got minus 5 is equal to LCM of 6. This will give me 9x plus 4x, and that will give me minus 30 is equal to 13x, and x will give us minus 30 over 13. And if x is minus 30 over 13, y must be equal to, well, going back to our equation of the line, minus 2/3 x, and x, of course, we know now as minus 30 over 13. So y must be equal to 20 over 13. So we have our values of x and y. Now we need to find the distance AB, because in our question it says find the exact least possible value of mod z. Leave your answer in the form of a root 13, where a is a rational number. So the distance AB, distance, here we go, distance AB, and it's the minimum distance because they asked for the least minimum, will be the mod z, which is your mod z, that is mod z, is equal to, and there you go, x squared plus y squared, which is minus 30 over 13 all squared plus 20 over 13, which is your value of y, 20 over 13 all squared. And that implies that the distance, minimum distance, is equal to, and that will give you 10 root 13 over 13. And this is your D min. Okay, and that's it.